Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 3233. Find the count of numbers which are not special. You are given two positive integers L and R for any number x. All positive divisors of x except x are called the proper divisor of x. Okay, and a number is called special if it has proper divisors as 2. Okay, and number 4 is a special because it has only proper divisor of 1 and 2, while number 6 is not a special number because it has divisors of 1, 2 and 3, right? Okay, and they will give a range, and we want to return the count of how many non-special numbers that are lying in between this range in inclusive range. Okay, fine. Let us see the example. See here. See this example. L is equal to 4 and R is equal to 16. Now, I return all the numbers in this range. Fine. Now, tell me which are the numbers that are special numbers and which are not a special number. I can say 4 is special number and 9 is special number. Other than that, all are not a special number, right? So, my output will be what? Output will be 11. Because the question is directly given that, see here, this 4 has only two divisors. What are they? 1 and 2. And this 9 has only two divisors. What are they? 1 and 3. While all other has 1 or more than two divisors. See here, 5 has only one divisor as 1. 6 has 1, 2, 3. And 7 has only 1. And 8 has 1, 2, 4. Can I understand this? Like that, every else has more than two proper divisors or one proper divisor, such that they are not a special number. So I am returning those count. Hope you understand this problem statement. Now let us see the brute force solution. Okay, so it is straightforward, right? I will just iterate through this all entire range, and I will take this number, this 4, and I want to find what are the proper divisor of it. So it is so simple, right? I just go from 1 to 4. Okay, 1 to 3. I don't want to take the 4, and I will check whether it divides 4 completely. That's it. And if the total divisor count is only 2, then I will take it. Otherwise, I don't take it. Right? So it is straightforward approach, brute force approach. Okay, what's the time and space complexity? I can say my time complexity will be O of n square, right? And space complexity will be O of 1. Okay. Now, whether we can optimize it approach. Okay, how to optimize it? Fine. So see here, for this 4, what are the factors? It is 1 and 2. Okay. For this 9, what are the factors? It is 1 and 3. So I can say it has 1 compulsorily. Every elements, every number have 1 as a factor. 1 as a factor compulsorily. Then I want only 1 extra factor, such that they are all what? They are all special. Right? Now we are just focusing on what? Special numbers. We are not focusing on not special numbers. First we can focus on special numbers. Okay. Now from this understanding, I can say some number have only 1 as a factor and another 1 number as a proper factor. Then I can say that as a special number. Okay. From this understanding, I can correlate this like, see here, if any prime number square is there, then obviously that factor will be what? That prime number at 1, right? Okay, listen this carefully. I have 5. 5 is a prime number, right? 5 square is what? 25. What are the factors of 25? It is 1 and 5 only. You may ask why it is possible for all prime numbers? Because see here, when I am taking 5 alone, I have only what? 1 as a factor. Okay, if I do a square, this 5 also be my factor, right? So I can say whatever the prime number, its square will be special number, right? So that's the clue number 2. Okay, just hold on. So see here 2 square is 4, 3 square is 9, and 5 square is what? 25, but we are not in that range. Okay, so up to this range there are only 2 possible special numbers. Apart from that, all are what? All are not special numbers. Okay, you may ask why 16 is not a special number, because 4 has what are the factors? 1 and 2. When I am doing 4 square, 4 is also added as a factor. That's why. Okay, 4 is not also a prime number. It is not a prime number. Okay, so that's the reason. Okay. Now, okay, how to find the prime number in an optimal way? Because prime number can be obtained in an optimal way and also in brute force. We don't want in brute force, we want in optimal way. Okay, so see here, I give you a quick understanding how to do in an optimal way. Okay, now if I want to go up to 25 numbers, then I will construct a array of 25 size. Okay, and initialize every element as what? 1. Okay, which means what? From 0 to 25, I am assuming all are prime numbers. Okay, now at first step, I will make this 0 and this 1 as 0, because they both are not a prime, right? Okay, this is the initial step. Then in next step, I point to this 2. Okay, now 2 has 1, right? This second and this has 1 as our value, which means what? It is a prime number. Then its multiple are not a prime number, right? So I will go here and change this to 0. Then go here, change this as 0. Like that, I will continue and change to 0. So 10 0, 12 0, 14 0, 16 0, 18 0, 20 0, 22 0, 24 also 0. Fine. Now the next step is I will go to this 3. Now for this 3, it is prime, right? So I will jump to what? 6. But 6 is already done. Okay, I will note this. Okay, now I'll go to this 9 and I will change this. Then 12 already changed. Then 15 I will change it. Then 18 already changed. 21 I will change it. Then 24 already changed. Okay, now it's time to go to the next one. Next one is 4. 4 is already what? 0, which means what? It is already not a prime number. So I will go to the 5. 5 is 1. Okay, which implies what? It is a prime number. So 10 already changed. 15 already changed. 20 already changed. 25 is not changed, so change it. Fine. Now I will go to the next value. What is the next value? Next value is 6. 6 is already what? 0, so it is not a prime. So I will go there. And 7 is what? 1. So it means what? It is a prime. But 14 and 21 are already changed. Okay, now 8 is not a prime. No, 11 is a prime. So I will go to the 22, already is changed. Okay, then 12 is not a prime, and 13 is prime, but it is out of 1. It goes to 26. Beyond this, there is nothing, right? There's nothing. So I will stop here, and I'm just observing that until this 5, I gone abroad or ahead and changed everything as 0, right? Behind this 5, I haven't taken any one of them and changed those values, right? Because when I'm taking this 7, already 14 is changed and 21 is changed. So I can say up to this 5 only, I taken each and every prime numbers and gone ahead and changed them as their multiples as what? Not a prime, right? Okay, so this is the first observation. Okay, then the second observation I have done here is, listen this carefully. When I am taking this 2, where I started at 4. When I am taking this 3, my 6 is already changed, so where I started from 9. Okay, when I am taking this 5, already every multiples of 5 is changed. I gone to what? 25, which means what? 2 means 4, 3 means 9, 5 means 25, which means what? I started from square. Can you understand this? I started from square. So how I am iterating? First of all, I am iterating through where? Through 0, from 2 to square root of n. Okay, inside that, if my current index, if I am taking this array as prime, if my current index, okay, is equal to 1, then only I want to proceed, right? Then only I want to proceed. Like Again a for loop for j. From where to where? From I star I. From square. If it is 2, I am starting from where? From 4. If it is 3, I am starting from 9. That's why I star I. And I will go up to what? Go up to n. And then I will jump up by what? By I. If it is 2, I am jumping 2 times. And changing each and every value as what? 0. That's it. So this is the optimal way to find the optimal way to find the prime numbers in the interval from 1 to something like n. Okay, what's the time complexity for this finding prime number? It is O of n log of log n. Okay, and space complexity is what? Space complexity is up to n. Okay, because I will take this array size, auxiliary space. So this is for the prime number alone. Okay, now we have founded a logic behind the special number and also logic behind the optimal way to find the prime number. Right now, merging these two things, I can conclude that whenever there is an interval like 4 to 16, I will take this 16, okay, and I will generate all prime numbers which is less than the square root of 16. Why I am taking square root of 16? Because see here, what is square root of 16? It is 4. So I will generate what? 2, 3 and 4. Okay, up to this, what are the prime numbers? The prime numbers are 2 and 3. And what is 2 square? It is 4. What is 3 square? It is 9. So I can say these two numbers are the special numbers. So what are the numbers that are lying between these two intervals? That is 16 minus 4 plus 1 is equal to what? So it will be something like 13, right? 13, and 2 are special numbers. So 13 minus 2 is equal to 11. So 11 is my answer. Can you understand this? So I am just taking the rules and I am just putting them, and I am just taking those prime number and squaring them to find the special numbers. Okay, and I am just subtracting all the values inside that interval with its special number to find not special number. That's it. Let us see the codes to be clear with the topic. See here, n is equal to int of r star 0.5, which means what? R square root plus 1. Okay, now prime is equal to 1 star n, which means what? I'm just assigning the size. If it is 16, then 16's root is what? 4. Then my array size, this prime array size will be what? Up to 4. Okay, now prime of 0 is equal to prime of 1 is equal to 0. Prime of 0 is equal to prime of 1 is equal to 0, which means I'm just taking the first and last, 0th and first in this and making them as what? 0. Now for I in range of 2 to square root of n plus 1. That's what I have told in that drawing explanation, right? This 4 lines. Now let us go here. The result is equal to r minus l plus 1. I am taking all the number inside the range as our result. Initially, I am assuming. Now for I in range of n, if prime of I, okay, if prime of I, then if L is less than equal to I star I is less than R. Okay, I'm just checking whether that prime number lies between my L and R. That prime number square lies between my L and R. Then I will just subtract 1 in my result. Okay, that's what. Then at last I'm just returning my result. That's it. Let me submit it. Yes, it is submitted successfully. Thank you.